And welcome to SOLIDWORKS Skills video.
One question I get fairly often from students who are beginning to use SOLIDWORKS is how to create threads and springs and other helical objects that have a realistic look to them. In this video I'll be demonstrating how to create a bolt with a thread. This happens to be a 1/4 20 thread, and we'll also look a little bit at how to find out what the dimensions ought to be to give you a realistic looking thread and dimensionally fairly close. Now keep in mind that threads are a little more complex than what I'm showing here, but it will get you started, and if you do your work carefully enough, it's likely you'll be able to create something that can be 3D printed. So here's a 1/4 20 bolt. The head, notice the head is very simplified. If it was a realistic looking head, it would have various chamfers and softening of the edges. I'm not going to demonstrate that in this video. So we'll start out, we're going to create a new part, and we'll start by creating the head of the bolt. It's a hex head bolt. That's a fairly simple feature to create. An extruded boss base, draw a polygon, a 6-sided polygon or a hexagon, and we'll dimension the head. Now this is a good thing to look up in Google. I happen to have a chart here, I'll bring it over on top, that shows the various dimensions that are useful when modeling a bolt. So this shows a hex head bolt. It happens to be a 1/4 20. And the thing that I'm really looking at here is G. I want to know, to begin with, what's the distance across the flat of a 1/4 20 bolt, and it shows that it's 0.438 inches or 7/16 of an inch if you want to use fractional. So we'll move this out of the way for a moment, and let's create the polygon, and I will dimension across the flats from here to here. They're all the same, and I'll make it as I just mentioned, a 0.438 inches. It's now dimensioned. I also noticed that my precision is 2 places. Let's go up and change it to 3 places for the document so that future things that we add will be 3 place. So I go into the document properties, dimensions, and I change the primary precision to 3 place, and now I have 0.438 showing up flat to flat. I will accept that. Let's also orient this. I'll make one of the sides horizontal. So actually let's finish out. I don't want to do another line. I'll push escape a couple of times. I'll click on one of the existing lines and make it horizontal. And you don't have to do this, it's just something that makes life a little bit easier later on. So I'll accept that sketch, and now it wants to extrude the head. Let's go back to our chart for a moment, and I'll look to see what is the height of the head of a bolt like this. That would be the F dimension of 0.163. So let's enter 0.163 here. I'll highlight that, 0.163. There's my extrusion, and now I have a head of a bolt. Now let's draw the shank of the bolt. Now if we're doing a 1/4 inch bolt, that means that the major diameter of the bolt is 1/4 inch or 0.25. I will do an extruded boss base. Let's start at this plane. Draw a circle which is centered on the polygon. I'll just draw the circle arbitrarily right now. Let's go in and dimension it. Make it 0.25. And now we're ready to create our bolt. I'll make it an 1.5" bolt just to have a reference. So 1.5. And now here we are with the beginning of the bolt. I'll accept that extrusion. Most bolts have a chamfered end on it. I will add a small chamfer to it. The chamfer is under the fillet tool. Click on fillet and then chamfer. Click out here. Now that's way too dramatic. Let's make it a much smaller, like a 0.03 chamfer. That's more realistic. And here we are. Now we're ready to start drawing the helix and the cut shape for a swept cut that will form the thread in this bolt. In order to create the cut thread, it's a three-step process. The first step is to create the helix, which is the path for the swept cut. Then we'll draw a sketch, which is the cross-section of the thread itself to be cut, and then finally we'll do the swept cut and form the groove that is the thread. When you are working with SolidWorks, you'll notice that, for example, I'll look at the sketches that are in these various features, and this one right here, this sketch, which is the circle, we want to have that circle be available for the helix, but it is consumed by the extrude operation. Thankfully, in SolidWorks, you can derive a new sketch from an original or from an existing sketch and use that for future operations. I will demonstrate how to do that right now. So first of all, we click on the sketch we want to derive. Click on the plane, which is the same plane, by the way, that the sketch currently exists. I will push the Control key on my keyboard and click on that plane. Now I go up to Insert, search for, let's find it here, derived sketch. It's down around 2/3 of the way, and we'll create a derived sketch. And notice that that new sketch shows up in the feature tree. Now we'll be able to use that sketch for new features. Well, the feature, let's accept the sketch, nothing more to do to it, we're just copying that sketch. We will create a curve, which is a helix, and we'll use that sketch, that derived sketch, for my helix. And notice that it jumps to action. Here's a helix that we could create. And first of all, let's look at the different options that we have up at the top, defined by pitch and revolution, height and revolution. I would say the thing I want to use is the height and the pitch. Those are the two controlling or independent variables that I want to use. So I'll click on height and pitch, and you'll see that the helix is going a certain direction. If you want to make it go the other direction, as in counterclockwise versus clockwise, I would click on that, and you can see that the thread, or the helix, which will become the thread, is going in one direction. That's clockwise. I'll click to counterclockwise, and you can decide which one makes sense for the cut thread that you want to create. It turns out that counterclockwise for an external thread is the appropriate direction. So we'll leave that. The next thing we want to look at is the height. Now you can type in a number. Let's say we know that it's 1.5 inch bolt that we're dealing with. I could type in 1.5, and if I move this out of the way, let's see if I'm able to. Yep, you can see that the thread would stop, or the helix would stop, at the limit of the screw. Another way of handling this is to simply drag the arrow, and you can manually define. It's okay to, in this case, to go beyond the end of the screw, because when it finishes cutting material, that's it. It's done. There's no more screw, so it does not create an error to go beyond it. You may want to use that method. The pitch is a number which is the distance between the peaks of the thread, or in this case it would be from one revolution to the next of the helix itself. Since it's a 1/4 bolt, 1/20 is 0.05, and that is the appropriate number. But for demonstration, if I made this 0.1, you can see how the helix would become less dense. So let's put back in 1/20. You can put in an equation here, and that is appropriate for a 1/4 thread. Now also notice that there's a starting point. It shows right here with that arrow. See that point right there? That is the beginning point, or the starting angle of the helix. And because I started things in an XYZ framework, if you look at it, the YZ plane would contain at present that point. And that's kind of helpful because in a moment we're going to want to draw a sketch on that plane. So right now it's set for 90 degrees, again for demonstration purposes. If I change that, let me move this out of the way. If I change it to, for example, 180 degrees, you can see that the starting point has moved and now it appears to be in the XZ plane. I'll go back to 90. In fact, let's look at what 0 looks like. 0 puts it back. It's still on the XZ plane, but it's on the other side. So you can decide for yourself where you want it to start. I do recommend putting it on a convenient plane for sketching purposes. So we'll choose 90. I'll accept this helix and it's now visible, and if I move over the end you can see how I can touch right on the tip of that helix. Let's now do a sketch in that plane. Now it's the YZ plane. Let's go up to sketch, create a new sketch, and let's find the appropriate plane. Let's scroll out a little bit. It's not the front plane, not the top plane, it's the right plane. And there we are. Now we're in a sketch, and again there's the end point. Let's draw a triangle which represents the thread that we're about to cut. So I'll use the line tool. I will begin at that point, and I'm going to draw what looks like I'm drawing into the head of the bolt, and that's okay. I'm just going to draw an arbitrary triangle. You can see how it's not dimensioned or particularly well aligned at this point. Let's fix that. So I will accept that line, and the first thing I want to do is to make this top line, let me come out of line mode, I'll make this top line horizontal. So now when the thread is cut, it's based on a line that is horizontal, or in essence in line with the shank of the bolt. The next thing I want to do is to align the center of this. There's the center of that line. I'll click on that. I'll click on the bottom here, shift click, and I'll make them vertical so that they're in a line with each other. That's okay. Let's accept that. Let's do some dimensioning. Now we know this is a 1/4 20 bolt. 1/20th would be 0.05. However, if you look at the typical shape of the top of a bolt, the top of the bolt has a flat to it. I'll move a diagram in that shows, you can see how there's a flatness to the external thread. So we want to have this triangle allow for that. So I'm going to make it something less than the full pitch, and I'll make it so let's go back to our drawing here. I'm going to dimension this guy, dimension it, and right now if I made it 0.05, that would yield a sharply pointed thread, which I don't want. So let's cut back, let's come back a little bit to make it 0.045. That's giving 5/1000ths of flat for each tip of the thread. That should be adequate for what we're doing. We'll accept that. Now we need to look at the angle. Notice that this, let's come out of dimensioning mode, this angle probably isn't correct. Right now it's not set to anything. Let's bring our dimensioning back and look at the angle of a typical thread, and you see that over here there's a 30-degree angle between vertical and one wall of the thread, which would mean there's a 60-degree included angle there. So we'll go ahead and create a 60-degree included angle. Let's come back here and we'll dimension one more time from here to here. Right now it certainly isn't 60 degrees. I'll make it 60. So there's my 60-degree angle, and that will set the extreme point down here. But just like I didn't want a sharp top to the thread, I also don't want them. If you look again at the diagram, the bottoms are significantly cupped. Let's model that approximately, and we would do that by adding a sketch fillet to the bottom. Now right now it's 0.1, which is way too big. Let's try 0.02. Click again down here. That's again too extreme. Let's go to 0.005. That looks about right. If you were doing this accurately, you would go to the various reference documents and find the exact numbers. Right now I'm doing more of a cosmetic look than a precise numeric equivalent. So I'll accept that. So here I am with this nice shape. It's mostly triangular. It has a symmetry to it. It's a width that will work and give me a flat, and I have my cupped tip down here. I'll accept that. Finish the sketch. So here I am with a path, a helical path, and a profile that I can use now for my swept cut. So let's go ahead and do the sweep cut or swept cut. Click on that. It's already selected sketch 4. If it hasn't, you would select your profile. The path is the helix. It will probably take a moment to calculate. I'll accept it. And now, with any luck, here is my cut thread. The helix is still visible. I'll click on that. I want to hide that. And here we are with our cut thread on a bolt, looking pretty good. And it has a chamfer at the end. This probably would 3D print okay on a good printer, and it is very representative of a 1/4-20 bolt.
Thank you for watching. This video is part of a series created by Neil Rosenberg and Joseph Caswell. All rights reserved.